Okay, now we can also convert from Cartesian coordinates to polar coordinates. However, the situation is complicated because there are many representations of a point by polar coordinates. If you recall, for instance, if we describe this point as r comma theta, moving counterclockwise theta and then r units away from the origin, we could also describe it by moving theta plus pi counterclockwise, putting us in this direction, and then moving backwards the same r units. So this would also be the point given by minus r and a theta plus pi angle. Well, at least we still have the triangle, which describes the relationship between the x and the y and the r and the theta. But what we need to do this time is find r and theta that satisfy our xy versions of measurements on the triangle here. So the basic ones are, again, the Pythagorean theorem. That's a clear way to take the x and y measurements of those sides and use a computation to get r. Okay, you just have to be aware that there are multiple solutions here. You could have r equal to plus or minus the square root of x squared plus y squared. Okay. Similarly, we can find a relationship for theta by using a trig function. And the best we can do is use tangent to take the opposite side divided by the adjacent side. Calculation is the same as tangent of theta. Unfortunately, this is not the same as arctan. Theta is not equal to arctangent of y over x. Why not? Well, because arctangent has a range. So this is one piece of our complication right here. Arctangent only takes a value between minus pi over 2 and pi over 2. Because that's where one period of the tangent exists and where we defined the inverse function. So a little bit of review from our earlier chapter 6.6 might be in order there. Well, so let's think. We have all sorts of solutions to these equations. There's multiple values of r and many values of theta as well. Okay, so we need to pick out the appropriate pair. Unfortunately, not just any combination will work. So here's an example that shows you how things can go right. Suppose we're looking at a point 1, 1 in the first quadrant. Okay, that's xy coordinates, Cartesian coordinates. Then solving my r and theta equations, okay, my r value would be r squared equals 2. And so I can look at plus or minus root 2 for r. And tangent of theta is equal to 1. If you remember values for tangent, then tangent of theta is equal to 1 when we have a isosceles triangle right here. Y and x are the same value. And that happens at pi over 4. But because tangent has a period of pi, it means it also happens at right over here, 5 pi over 4. And again, it'll just keep repeating. So we actually have infinitely many values of theta that satisfy it. Here's pi over 4, and then here's 5 pi over 4, that's plus pi. Add another pi, we're at 9 pi over 4, add another pi, we're at 13 pi over 4. So we get all those, pi over 4 plus any multiple of pi. Now, can we just take any r value that solves this equation and any theta value that solves the tangent equation? Unfortunately, no, we cannot. For instance, if I were to take r and theta to be the plus root 2, and I grab the 5 pi over 4 for my theta, then what point does that actually describe? Well, 5 pi over 4 would put me in quadrant number 3, and root 2 would say walk in that direction, positive root 2 units away from the origin. So that would mean it was describing a point in quadrant 3, minus 1, 1, and not the point 1, 1 that we were after. Okay, that's a problem. In the same way, you could also get the wrong answer if you chose minus root 2 for your r value, but then happen to choose pi over 4. Pi over 4 would tell you to look at the first quadrant, but then minus root 2 would tell you to walk backwards root 2 units, again landing you in quadrant 3 at the point -1, -1, instead of 1, 1 where we wanted. Okay, so you have to be careful about what you're doing. You have to think about what quadrant you're in. Okay, so for instance, if I want to finish this problem appropriately, then using my r is equal to pi over 2, which theta should I have actually used? 5 pi over 4 put me in quadrant 3. I didn't want that. I want to be in quadrant 1 for this point. So that means I should actually be using the pi over 4. So for instance, we could use r theta equal to root 2 comma pi over 4. That would work. Okay. Or we could use r theta equal to minus root 2. So that says to walk backwards. But if I'm walking backwards away from the origin, I would have to be looking in the opposite direction. So that would mean I would actually want the 5 pi over 4. So that I'm looking in the direction of quadrant 3 and walking backwards into quadrant 1 to land at the point 1, 1 that we want. Okay, so let's try doing that on a fresh example. We have a point in Cartesian coordinates -1 comma root 3. So that means we're given that x is equal to -1 and y is equal to root 3. And we've got to find r and theta for this point. Okay, so we start off with our basic equations that come from our triangle, right? There are these equations up here. R squared is equal to x squared plus y squared. So that would come out to squaring that is 1, squaring the root 3 is 3. So I would have r squared equal to 4. And so r itself could be taken to be either plus or minus square root of 4, giving me two possibilities. So I would say, just pick one at this point, and the easiest one is usually the positive one. So you can just think about walking away from the origin in the forward direction. So we'll choose r is equal to positive 2, emphasize the positive there. Now we have to figure out a value of theta to go with that. So we also need to solve the equation tangent of theta is equal to y over x. Okay, so that boils down to tangent of theta is equal to root 3 divided by -1. So that's a minus root 3. Okay, now you probably don't memorize values of tangent. Like I said, you should only be memorizing values of like sine and cosine in the first quadrant. So actually the easiest way to proceed is to start by writing tangent in terms of sine over cosine. Remember, what we're after here is a theta value that solves this equation. And remember that sine is actually an x opposite side divided by the hypotenuse, so y over r. And cosine is actually adjacent side divided by the hypotenuse, x over r. So for instance, we would be wanting a pair that solve these two equations when r is equal to +2. Okay, so we actually, from here, see that we actually want to solve sine theta over cosine theta is equal to the y value over r being a root 3 over 2, and the x value over r being -1 over 2. Okay, so that means what we actually want is to solve two equations simultaneously. We want sine of theta to equal root 3 over 2, while cosine of theta should be equal to -1 over 2. Okay, and if we do it that way, then the only sort of redundancy that we might get, we're going to have many thetas that solve these equations, will be the redundancy not of this opposite kind, but of the kind that moves 2 pi around the unit circle. Okay, so I suggest you actually solve them this way. And remember what quadrant we're in. We want to solve those. Let's see, x is -1, and it's a minus sign, and y is positive. So that means we're actually in quadrant 2. So that means we want to solve these for theta in quadrant 2. That would be theta being from pi over 2 up to pi. Okay, and if we do that, we can know which ones we actually want. So sine of theta equal to 3 pi over 2. That happens at pi over 3. Remember, our picture is actually going to want to look something like this. Let's move over here. And we've got our point -1√3 over here in quadrant 2. And we actually know that sine of theta would be pi over 3 to make this √3 over 2. That's the value that you should memorize. Okay, so we actually know that this side should be pi over 3 in order to make this happen, in order to get our y value correct over there. Okay, now our x value is actually negative though. Okay, so instead of just saying sine of pi over 3 being equal to √3 over 2, instead we want to move that to be in the quadrant that we're after, quadrant 2, because the pi over 3 is really talking about this triangle right here. Okay, that's positive pi over 3. And our y value, and this would actually be minus x. R is 2. That side is 2 there. Okay. So we don't want theta equal to pi over 3. We want theta equal to pi minus pi over 3. So that we actually get this angle right here. So we'll choose theta equal to pi minus pi over 3, or theta equal to 2 pi over 3. Okay, and so we get our description. R theta can be described, describes the same point if we use r equal to 2 and theta equal to 2 pi over 3.